My high school actually had a planetarium. The astronomy teacher was really fundamental in nurturing my interest and let me, turn off the lights and be in the planetarium all by myself. And that was just such a powerful experience and really inspired me and made it feel like this is something that I can actually do. I'm an astrophysicist at the University of Texas at Austin, and I study some of the most distant, most massive galaxies in the universe. I lead a program called Cosmos Webb, which is one of the largest programs undertaken with the James Webb Space Telescope, which is the successor to the Hubble Space Telescope. It can see objects 100 times fainter and much further back in cosmic time than we could see just a couple years ago. We just finished assembling this incredibly large, deep image of the cosmos, and we are just now starting to sift through the 1 million galaxies that sit in this single image. We're trying to find the most massive galaxies that really push at the extreme margins of what the universe can produce. And by finding those extreme sources, we get to test fundamental laws of physics.
Her work is really incredibly fundamental and foundational and asks these amazing questions about what is the origin of the universe, using the highest technology that we have today to look as far back in time as possible to really see the emergence of the earliest galaxies in the universe.
A big surprise when JWST first turned on was an overabundance of very bright galaxies at early times. We were not expecting this at all. We maybe expected 10 or so galaxies at these extraordinary distances. We found 100.
I trace the evolution of the biggest, most distant galaxies in this image as they are forming and evolving over time. So I look at specifically the big fireworks shows going on in the first 2 billion years of the 14 billion years of our universe and try to figure out how that seeded the universe that we see today.
They had to have had some sort of very efficient process of forming their stars, of forming their black holes that we just don't see in the universe today.
We're seeing more galaxies, bigger galaxies, brighter galaxies. The universe assembled itself in this complex way more rapidly than our theoretical models can predict.
What we can do is not just find the most distant galaxies, but find where they live in the biggest structures known on the largest scales of the universe.
At the end of the day, her impact, the lasting impact, is going to be the students that she trains and the postdocs that she trains.
We have such an amazing role to play in the lives of students. And part of my mission as an educator and as a mentor is to just keep the fire going in people's minds about how interesting it is to be able to solve the mysteries of the universe from this little rock we live on.
She is a supportive mentor. She is a really thoughtful, conscientious teacher. She is involved in her own science and manages to juggle all these things and excel at all of them.
One of the most exciting things about astronomy is that it's impossible to predict what we're going to find next. There's so much to learn. I don't know what the next surprise is going to be, but I'm here for it.